Hello and welcome to Group 37's Spaghetti Bridge Report. We were tasked with building a bridge out of spaghetti that would span 350 millimeters. The bridge was supposed to be as lightweight as possible, holding the most load. My group decided that the Warren Truss structure would be best fit to achieve this task. This is due to the truss structure's efficiency in distributing forces through triangular pattern. The first step of actually building the bridge was to draw out 1:1 scale drawings of the bridge onto A3 paper. You can see our group's prototype structure contained 4 triangles spanning across the Warren Bridge. This bridge was quite wide, almost reaching the maximum of 80 millimeters across. We used Selleys superglue as we were instructed to via the assignment sheet. As you can see here, our spaghetti members being cut to size in line with the 1:1 scale drawing. We used masking tape to hold together the pieces while they glued, to ensure they glued properly together. Once all of these individual members had dried, it became time to glue these members together. This is what one side of the bridge looked like. You can see the elements that make this specifically a Warren Truss bridge. Once all the elements of the spaghetti bridge were built, it became time to glue everything together and prepare for testing. Our prototype bridge weighed just shy of the maximum of 200 grams. We placed the spaghetti bridge on top of 2 paint cans, with a hook going down to a bucket that would be filled with rice to show how much weight the prototype bridge could lift. The bridge reached failure with 3 kilograms of rice in the bucket underneath. That shows our spaghetti bridge failing in the center, where the bending force is the strongest. The bottom strands stretch in tension until they snap. With our second bridge, we employed a simpler design, still a Warren Truss, but now with 3 triangles. It should be simpler to build and more structurally stable, also shortening up the width of the bridge from 80 millimeters down to 50. On designing our main bridge, we found Glad Wrap to be a superior alternative to masking tape, able to hold the spaghetti in place at a much higher standard. We then used a Stanley knife and cut to measurements so we could get the spaghetti lengths the exact correct size. We found it far more efficient to cut fully glued together strands to size rather than to cut to size first and then glue the strands together. We decided to create the top and bottom chords of this bridge, intent to design in a different process than the first prototype. We started building up from the bottom chord, which we had reinforced to prevent the same snapping in the center that had happened on the first bridge. We then had our completed bridge ready to test in class, interested to see if the reinforced central bottom chord would still cause the bridge to snap in tension. Our second bridge weighed in at 214 grams.
Zero.
We haven't even started yet.
You're moving.
There it is.
Move now. Yeah. 3, 4,
Yeah, take a video next time.
5, 5.
Wait, keep going.
Kind of funny, but what's it now?